Hello everybody. It's been a while since I've made an actual math video, so to speak. I know I've been doing lots of music and animation stuff, and I'm really enjoying that, by the way, but that's definitely a work in progress. I'm a little bit more stable on how to do math than I am on how to animate and make music. But I've been seeing so many things on Instagram and Facebook and YouTube and just all these different posts with all these different math problems. And they're great. I mean, it's good when I see them. It makes me want to go do them just, for fun. I know I'm a little bit of a math nutter. But also when I see them, I actually want to make a math video and show how you can concretely build them rather than just use algorithms or memory or not like your typical way, I guess. I like to show how it can be, I don't know, my opinion, it's a bit more fun when you build them. So this is one that I had seen on, I don't know, somewhere, and I had made a note about it, and I had wanted to build it. But before we do that, I wanted to show you some pieces from the Basic Ops kit, the Mortensen Math Basic Ops kit. So these down here, these little ones here, those are our units. So that would just be like one. I'm fortunate enough to have some multi-units. So if I did two like that, I have a little multi-two right here. I don't know if you can see that or not, but it's just 1 by 2. And then also for the, if I had 6 of them, 1, 2, 3, 4, 5, 6. I have a 2 by 3, a little multi-unit. Okay. So I probably will use my little multi ones today, just to make things a little bit easier for me to put together. The Basic Ops kit does not come with these anymore. Those are basically vintage. All right. We're going to be doing algebra. So for algebra, this is going to be a 1 by x. So 1 across x up. So that would be 1x, 2x, 3x, and so on. These would be our x squareds. They're x by x. So that would be 1x squared, 2x squared, 3x squared, etc. A fun little thing that we can do with the x squareds is we can take them and stretch them out long and skinny. And this is what they look like when they're stretched out long and skinny. So this would also be an x squared. So 1x squared, 2x squared, 3x squared, 4x squared, 5x squared, 6x squared, right? These are an x squared by an x, which, can you guess what it is? It's an x cubed. Okay, so these are the pieces that we have. We've got our units, our x's, our x squareds, and an x cube. I do have an x to the 4th, but we're not using that today. And the x to the 4th is just a giant big blue square, which is an x squared by an x squared, if you can imagine. All right, so back to the problem that I had seen posted. It was this here. So this just says that we're multiplying x plus 1 by x plus 2 by x plus 3. What we're going to start with those, the first two. We're going to go x plus 1 across and x plus 1 up. And all we need to do there is make sure that it's x plus 1 across by x plus 2 up. Okay, and basically all you do is you just fill that in. Now I could put it this way so it might be a little bit easier for you to see. But it's going to be that, x plus 1 by x plus 2 across. So let's just fill in. You can see it's x plus 1 by x plus 2 going up. I'm just going to get rid of my measuring sticks there. And we just have to fill in the corner. So can you see that this is x plus 1 across anywhere you go? And it's x plus 2 anywhere you go. Sorry, I don't have an extra 2 there to hold up. I'll hold that one up. Let's put these in the corner for now. That way you can see it's actually x plus 2 anywhere you go across. Okay? All right, so x plus 1 plus x plus 2 across is just the same as, what did we call these again? This is an x squared, right? Plus 1, 2, 3x plus 2 more. So that's what this is right here. Okay, now what that is that it just tells me, actually I have this here, it tells me that now I'm going to have an over distance here of x squared plus 3x plus 2 and an up distance of x plus 3. Okay, because in this case here, sorry, it's a little bit smudged, when we did x plus 1 times x plus 2, this was my over distance, and that's my up distance. Okay, and you can see my over distance is x plus 1, my up distance is x plus 2. That's how we do multiplication in Mortensen math. The first one's always our over, and the second one's always our up. Okay, so now that gives us this. And this is the same as that. Those two things are the same. Can you see that? How those two things are the same? Okay, so now taking this back to this card here, well, x plus 1 times x plus 2 is the same as that. But now we have a new rectangle we're going to build, and this is going to be our over, and this is going to be our up. And what we need to do in order to do that is take this and break it apart, make it long and skinny. So I'm going to just replace this with this, okay? And then I'm going to add these to the end of it. See, I'm just breaking this rectangle up that we just built, like this. And this is going to be our new over distance. But we also need it to go up x plus 3, right? So it's going to look something like this, x plus 3 up. Let's just use the 2 and the 1 here. So you can see that it's going to be a big, long, skinny rectangle. Okay, so to start building this, I am going to put this right in here. And I'm going to put these up in here. And I'm just going to take my measuring sticks off here. Okay, you can still see that it's x plus 3 up there. But I have to keep building over here because it needs to be a little bit longer. Okay, so I'm going to make it, just add these in here. Add these in here. And it needs to be plus 2 more. All right. And then I need a 3x here. And it looks like I'm going to need another 3x. And it looks like I'm going to need another 3x because we need to build a rectangle, right? That's what we do. We build rectangles. And then I need 6 in the corner. So rather than using these 6 little tiny ones, I'm actually just using a multi-unit here, which is a 6 bar. I'm thinking I'll just move this up just slightly so it's more centered. Hopefully you can see that. Maybe turn it this way a bit. All right, so now what we've built is this big long rectangle. Now, I don't know if you can see, but if you look at the top, it's a little easier to see it at the top. We have an x squared plus 3x plus 2 across the top, which is what we're looking for, right? X squared plus 3x plus 2. And going up, we have x plus 3. And that's the same whether you go across here, 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 or go up, here, here, anywhere you go up. So these, the across and ups are the same no matter where you look on this rectangle. Okay, so now you ask, what do we do next? Well, all we do is we count. So we count what we see. Well, we have an x cubed. We have 1, 2, 3, 4, 5, 6x squared. We have 3, 6, 9, 10, 11x, and 6 units. So the big green one, x cubed, 6x squared, the 6 red x squareds. We've got 11 blue x's, and we've got 6 green units. Okay, and that is this with a couple of steps in between, right? So normally we're just taught to multiply this out, you know, show all our symbols and everything. But I think it's really good for kids to be able to build these things first, because if you're a little kid or a big kid or an adult and you were given this, how would you know what this was if you'd never seen one? Well, you wouldn't. So you need to be able to see one first, maybe even touch it, feel it, play with it, in order to understand that this is the same as that, right? Well, this is the same as this, right? It's concrete. So you touch it, you build it, you see it, you feel it, right? And then the next step is you could draw it, right? But we won't go into that today. I just really, really wanted to show you how this worked. Actually, you know, why don't we draw it? Let's draw it real quick. Why not? Let me grab a couple of markers in the colors that we need. Do I have a couple of markers in the colors that we need? I do. And I am going to grab this. I'm wondering if I can draw it on one of these cards, because I'm always getting markers all over myself. All right, so what do we see? Well, we see a big green rectangle. Okay, let's draw the big green rectangle. These will not be perfectly, you know, to size, but, and then we see that we've got 1x squared, 2x squared, 3x squared. So we've got x cubed, 3x squared. We need some more x squared. See, we need 6 of them. So we'll put one there, one there, one there. Okay, and now we need some x's. We need 3 up there. So 1, 2, 3, 1, 2, 3, 1, 2, 3. And we need 2 on the side. And to fill this in, to make it into an actual rectangle, we need 6 green units in the corner. So that's how we would draw it. Now, you don't need the colors to draw it, but it sure makes it more fun when you do the colors to begin with. And also, it's very visual. You can see I've got an x cubed. I've got 6x squared. I've got 9x plus 2x, which is 11x, plus I've got 6 units in the corner, right? So what we're drawing matches what we're seeing, all right? From there, then you can go into the algorithm and see how that all works. And that is not what we're touching on today. Today, I'm just showing you how to build it. Something a little bit more advanced than what I have been doing, like showing, I guess, not what I've been doing. I've been working in up to Calc 2 this year, a little bit into Calc 3, which is very interesting. You know, all the way from basic counting to addition, all the way up to the beginnings of Calc 3 is what I've been working on this year. So quite a range. So somewhere in the middle, I would say this sits a little bit in the middle. If you have questions, just ask. And also, don't forget, I am doing some office hours on Fridays. So if you want to be part of that, you know, get in touch with me, and you can have your own individual time with me. Just, you know, or if there's more people that want to talk about the same thing, we can put you guys together. But lately, it's been mostly individual time for individual people, just so that they can get the help that they need on what they need. All right, well, that is going to be it for today.